Hey there, Polysthetics. Welcome back to the Andromedoom devlogs, episode number 3. If you'd like to skip ahead to the content, please check the timestamps in the description below. In this episode, I'm going to be picking up where I left off from the last one, where I set up keyboard controls for the player and the camera. What I'm going to do now is set up touch controls for the camera, and this is in the form of a rectangular area on the screen, where you can drag your finger and that will move the camera. And in today's devlog, I'm going to be presenting some of the buildings I put together, specifically Sydney and Singapore, which was what I got to this week. Alright, let's switch over to the screen. Following on where we left off, camera controls with the W, A, S, and D keys, keyboard controls, and joystick controls. And what we want to do next is setting a drag control for that camera, so we don't have to use the keyboard when we're testing this on the touchscreen. Step 1 is setting up a region that will receive touch inputs, and we do this with the touchscreen button. Now we could put it under the UI node. We could also put it underneath the camera. So just keep in mind as your project evolves, if you're using my system, that you'd have to pay attention to how the transforms of the parents might affect the 2D elements. I like to keep everything user input underneath the canvas, so I'm going to do that instead. Now here, let's add a child node, touchscreen button. Now my screen resolution is 1540 by 720, something like that, just to match with my phone, with my touchscreen device. For now, let's leave everything as is, and we'll update the size and location of this button in a script. That way, if your screen resolution changes, the region that picks up the camera controls is scaled relative to the screen size. These here are absolute numbers. Camera. Let's attach a script in C#. So step 1 is setting the size of the touchscreen button. Now recall in the editor that the touchscreen button takes a rectangle shape 2D object, which represents the region that detects touch. So we need to create a field of the type rectangle shape 2D. We'll call it touch rect, and we'll initialize it. Now the shape of this rectangle is represented by a vector 2, the width and the height, and it's stored in a property called extents. So touchRect.extents. So what's it equal to? Well, it's relative to the size of the viewport. So if we get the viewport and we get the size, this returns the width and the height of the viewport. Now we don't want every touch on the screen to affect the camera movement. So we'll take the extents, which is half the size of the rectangle, we get the viewport size. So what we'll do is multiply it by some value that shrinks the size of the rectangle. So I'm going to say 0.3. And a better way to do this is, of course, with a field, which we should export. Call it an extent multiplier, and we'll just set it to a third, so that the size of the touch rectangle is about 60% of the screen. So we've set the shape, now we need to set the position. The way the position is set is you take the size of the original rectangle, you subtract the size of your touch area, and then you divide by 2, and that's your offset. So get your viewport size, and if you look at the algebra, this is the same as 1 minus the extent multiplier, and then you halve it, so multiply it by half. Okay, now it's a bit difficult to understand what I did here, just looking at the code, so let's try and demonstrate it in the editor. So on the touch camera button, I'm going to put a sprite on the pressed texture property. So we can see when the touch camera region responds to touch input. Now I made a little boo-boo here. Remember, your extents are actually half the size of the touch rectangle. So when we're correcting for the position, we have to double this extent multiplier to get the actual size of the rectangle. So this is 1 minus the size of the rectangle, multiplied by the viewport size, multiplied and halved. That way it's perfectly centered. Now, as you can see, if I touch the outside edges, nothing happens. But if I touch towards the middle, we see the logo, and that's the regions that will pick up on the touch screen inputs. This is a quick and dirty way of visualizing it. Next thing to do is to pick up on drag events. And we're going to do this similar to the joystick input. It's going to be in the input function. Now again, I don't like using this ampersand operator, so I'm just going to rename this argument to input event. Now the first thing that we do every input cycle is check if the button is being pressed. And specifically here, I'm going to check if it's not pressed. That way we don't have to add more tracebacks. It's just a bit cleaner this way. Great. Now we check for the type of input event. Now remember, you don't have to do this in GDScript because it's based on references, but because C# is statically typed, you have to cast objects into the required type before you can use those object-specific properties. So we're going to check if the input event is of the type and inputs drag, and we're going to call it drag event. And if so, we need to keep track of the inputs received from these drag events. And so we'll want a field here, private vector2 called received drag, and we'll initialize it to 0. Now the input event screen drag has a property called relative, which keeps track of the current touch position relative to the last call. So it very simply picks up the magnitude or the speed of the drag. So it's just a question of setting the current drag event dot relative. And the tooltip tells you it's the drag position relative to the previous position. That's the position at the last frame. That's actually all you need. Now the next thing is to send this received drag to the camera. Now if you recall in the camera movement video, the camera is actually controlled by 2 gimbals here. One that controls the azimuth, which is its rotation in the XZ plane or about the y-axis, and its altitude. That's how it works, and the camera just sits underneath them. So to send inputs to the camera, we have to connect to this node, the signal. Now we can do this with the getNode function by passing a string of the path of this node relative to the root or relative to this node. Alternatively, what we can do is set up because there's only going to be one camera, we can set up a static reference to this spatial node. And in that scenario, we no longer have to worry about the structure of the scenes, and we can make this node responsible for setting itself in the scene hierarchy. Now, the way we do that is by creating a singleton object that manages this sort of thing. Let's go create a new script. We'll call it globals. Here its node, and we'll create. And so we'll create a property on this globals singleton to the camera azimuth node. So it's private of the type camera movement, because that's the name of the script that we've attached to the camera azimuth. We'll call it the camera gimbal. And we won't initialize it. Now we'll create a property called camera gimbal. And when we return camera gimbal. And when we set the camera gimbal field to the value passed in. And we want to make these static, so there's only one camera at a time. Now let's go into the camera movement script, and in the it's ready function, when it enters the scene hierarchy, go to globals.camera gimbal equals to this. Now that way, anytime an object wants to connect to the camera, all it needs to do is use globals.camera gimbal and not have to worry about the location of the camera in the scene structure. There's one other thing that we have to do. In the auto load, we need to select the global script and we'll add it as a node. So now we have a singleton reference to the active camera. What we can do now is, rather than setting up a signal, we can set a property, a public property on the camera movement script that then the touch camera script can just set directly. So in the camera movement script, we can create a new vector2, which we can call drag input. And we'll initialize this to 0. Now we'll check to see if there's if the keyboard input is 0. Now let's refactor this code a bit, because the rotation no longer only takes it from the keyboard. Let's rename this symbol to rotation. And so now the rotation gets the keyboard input, gets the output from the get keyboard input function. But if it returns 0, which means if there's no keyboard input, then we set rotation to the drag input, multiplied by delta, multiplied by speed. Now we need to create a property for this input. So public vector2 drag input. And when we just return drag input. In fact, we don't actually need a getter because nobody should care about getting that value per frame. So we just need a setter, and we'll set the field to value. And back in the touch camera, now every frame, or rather every physics step, we set the camera gimbal's property of the drag input to the receive drag, which we multiply by delta, so the camera doesn't go flying. And as you can see, it's responding to inputs. It's the drag event. Clicking outside won't affect the camera speed, but dragging here does. Now what's the problem? Well, the camera doesn't slow down. Now all we need to do here is linearly interpolate the vector, the drag input vector, back down to 0 every physics step. We can just do this with the loop function. So what we're doing here is using the loop, we're taking the last received drag from the last physics step. So it's the same value in a feedback loop, shrinking each time back down to 0. And the last one is a weight parameter. So we'll export another private float, and we'll call this camera inertia. And we'll set it to a half for now. We exported it so you can set it as you see fit. And we do the same for the Y value. So let's test this. And as you can see, dragging across the screen doesn't send you spinning infinitely. However, that is much too heavy. So let's drop the inertia to 0.1 and test it out. A little better, but still a bit heavy. but you get the idea. You can tweak as you see fit. Alright, that's all I had for today's walkthrough. Hope you enjoyed it. If you have any questions, comments, suggestions, please put them in that little box down below. And if you enjoy this series, don't forget to hit like, subscribe, and hit the bell as well. And tune in for the next episode. And now a word from our sponsor, me. I'm today's sponsor. Are you tired of having shower curtains that don't have pixelated cows on them? Do your shirts not have cool marble statues? Do you want to see my face on more YouTube videos? Well, if you answered yes to all three, and be honest with yourself, you did, head on over to polysthetic.threadless.com. You can get my merchandise plastered all over your chest, your coasters, and your walls. Head on over to polysthetic.threadless.com. Chuck a few bucks my way. Thank you very much, guys. Now, in the last devlog, I showed you the Bathymetroids, the aliens models I put together that will invade the Asia-Pacific region. And I also showed a time-lapse video of me creating one of them, the Goblin Shark. Now, you may have noticed that I don't use the sprite tile plugin. It's because the way I plan out the pixel maps, it's all in odd sizes, and there's a lot of angled elements. Sprite tile works well when you have a tile map pre-built and you work with regular sizes and you build up your mesh that way. It's a great tool. I just prefer to work using Blender's built-in snap to pixel tool. I think it works great. And one other thing you may have noticed, which I briefly touched upon, and I won't discuss in detail in this video, but it's the color schemes used for the aliens, how they were biased towards blue. Now you'll see that the Asia Pacific buildings will have this yellow biased pixel art palette, and I will discuss in a future video the methodology for how I pull together these color schemes. I think it's always best to limit yourself when using pixel art style to a very limited palette. Now, if you're from Sydney, you know that a lot of our civic buildings and our old grand buildings have a yellow tinge to them because they're made out of the local sandstone. So the choice of yellow for the Asia Pacific cities is kind of intentionally biased towards Sydney because that's what I'm familiar with. But I'm going to make it work with the other 5 cities. So let's take a look at Sydney and Singapore, which I managed to put together this week. 6 buildings each. After showing you the buildings, I'll discuss the criteria for building selection as well. So here is the Sydney Grace Hotel, a beautiful Art Deco building in the CBD. As you can see, it has that sandstone facade. Of course, the Sydney Harbour Bridge. I'm thinking about putting little graphics together that show the number of triangles, the color palette, and the texture outlet. Now notice all these little details here. That's actually through the alpha channel. It's not geometry, so these faces are actually flat. So I'd need to keep in mind when putting this in the Godot engine to switch off backface culling. I'll try and keep the meshes at a maximum of 300 to 400 triangles each, and a lot of them sit about the 100 triangle mark. Some of the really simple ones sit at even less, and it's all about optimization for the mobile game engine. And of course, here is the iconic Sydney Opera House. I might fix these details a little bit and pull these faces in so there's a bit of overhang on the concrete shells. And here is the beautiful Queen Victoria building located near Town Hall. The proportions of this one are quite realistic, but it might be a good idea to maybe rebuild this model and squish it in so it's a little more compact, a little more stylized. And here is Sydney's Centre Point Tower. Again, you can see the cable stays are built with an alpha map, so there's no extra geometry here. And again, it fits in quite nicely with the yellow color scheme. This one is a much loathed. I have a soft spot for this building. It's the Brutalist Tower of UTS. It feels like a city in a building when you go inside. But as you can see, its monolithic facade does not attract a lot of love from the locals. Now, I haven't been to Singapore outside of the Changi airport. They've got wonderful architecture. And none other, and this one is my favorite, the Singapore Art Science Museum, which I think is shaped after a lotus. I'm not too sure about the building, about my selection for this one. Maybe I'll swap it out for something else, something a little less abstract. But this is the Singapore Garden Domes. One of them is the Flower Dome and the other is the Cloud Forest. And these are some covered walkways. A famous residential building in Singapore is the Interlace, which looks like a bunch of Jenga blocks stacked up on each other. When I was younger and I played with Lego, I'd connect the 4x1 rods in configurations much like the interlace. I wonder if the architect had that same idea. And of course, everyone knows Singapore's Marina Bay Sands Hotel. Now this is a very beautiful building, and looks like it's something that could have come out of New York or Chicago, the Art Deco style, but it is indeed in Singapore, Parkview Square. Now Google Earth, well, the online Google Maps interface, has Singapore in 3D, and this is one of the buildings that is large enough where I can just use that Google Earth 3D model as a reference. And finally, maybe a bit of an odd choice, but it's Singapore's Pearl Bank Apartments. I like these donut shape of the floor plan and how well it fits in with the color scheme that I pulled together. And even when rendered in the pixel texture, they do look quite similar. And when taking a look at a long distance shot of the hotel, it almost looks like it is rendered in a pixel texture. Alright, that's 2 cities down and 4 to go, which are Hong Kong, Shanghai, Seoul, and Tokyo. I want to talk about the criteria that I consider when choosing buildings like this. And there are 3 things. One of them is not to choose too many skyscrapers, because all skyscrapers sort of look the same at the end of the day. And because they're all built from glass in the international style, all of them are going to look blue, which is not what I want. I want every region to have its own particular theme, its own color schemes. And the more wacky and the more personality that I can put into each level, which is based on a world city, the better it will be, the more memorable the gaming experience will be. And so that leads to not just avoiding skyscrapers, which big Asian cities have no shortage of, but also picking some of the most unique, iconic, differently shaped buildings. And Singapore was great for this, because you get to see a circular apartment block, an Art Deco building, Marina Bay Sands is iconic, the interlace is strange, and the Art Science Museum as well. There's a lot to see here. Even with Sydney, everything has its own sort of shape. And the final consideration is how well it fits with the color scheme. Surprisingly, your mind fills in a lot of the details. So if the building's famous enough, or when you look at it in the context relative to other art in that same color scheme, if something's orange but there's no real reds, that orange can take the place of the red. If something is tealish green and there's no deep blues, then that green functions as the deep blues. So your mind fills in the rest, and working with the limited color scheme is surprisingly liberating. You don't have to stress too much at how to represent what you see in real life onto the stylized artwork. The color scheme does a lot of the heavy lifting for you, so creativity can really thrive on constraints. Alright, that's all I have for today's devlog. I'm still just building art assets before I complete that vertical slice of the Asia Pacific. Hopefully next week I'll complete the other 4 cities, though it is looking a bit optimistic at this point. Tune in next time to see how I'm progressing. Now, if you enjoy these devlogs, if you have any comments, suggestions, compliments, insults, leave them in that little box down below. Hit like, subscribe, hit the bell as well, and I will see you in the next one. Thank you for watching.